Code.org, which is an hour of code that we're a part of at Rock Valley College, where we just demystify computer science. And we're doing it. It was such a success in December. We had like 126 show up between the face-to-face and online. And so to keep the momentum going, we're doing an hour the fourth Saturday of the month, Monday or January through May. This one I'm teaching this Saturday is going to be on Star Wars, a Star Wars app. And we're basically using an online program called Blockly that was created by MIT, and teaching anyone from 5 and up. In December, we had families come in and just basically spent the day learning about code. It's kind of cool. And so I don't know how many spots we have left. As of this morning, we had 4 spots left out of 20. There might be a few left, possibly. So you can again go to meyervc.org, or Rock Valley College EDU has a link to the event as well. That's this Saturday. And we'll be happy if you miss one this month. We'll have them next month as well in February. It's the 4th Saturday. And we just do 1 hour. I give a raffle giveaway. We talk about the courses we offer here on campus and programming, because only 1 out of 4 K through 12 offer computer science courses in America. 1 out of 4. So you can imagine when folks graduate high school, that's why we're having a lower, incoming campus-wide across the nation in computer science, and it's always been that way. It's not something new. It's always been 1 in 4. In fact, it might have been worse 20 years ago. It might be 1 in 4 might actually be a good number now compared to what it used to be. And so we're trying to expose younger generation, younger age, to computer science, that it's not scary, it can be fun, and you can create anything that you want to create. Sky's the limit. You're literally creating something that doesn't exist, like Mark Zuckerberg did, as an example. He's a little successful, maybe. And so, just a kid in a college dorm. And so, not to say everybody's going to be Mark Zuckerberg, but you can make a living. I've made a living as a programmer my whole life, and so you can make a decent living. And so, anyway, if you're interested, come Saturday, peek in for an hour. It'll be fun. It's not hard at all. Literally 6-year-olds can do it. So that's how hard it is. My grandson's done all of them. There's like 40 tutorials on the rvcrcode.com, and so anybody can do them. So any questions about Saturday event or the Hour of Code workshop in general? Okay, cool. Here is a screenshot of our meyervc.org website. I know I mentioned it last week. I don't think we went to it. Basically, you have on here on the right side some apps you can download for the division. There's a new one out called College Memory Maze. It's basically an app that students can download and play like a Flappy Birds type of game level, and then go right into a course selection of what they're interested in. And then it contacts the advisor here in our division and gives you a unique schedule web page basically developed just for you in your inbox. And so that's a new one that we just added, College Maze. So on the website, you'll notice all the announcements. You've got upcoming events, which is the Imagine Me coming up for high schoolers. Dester, which is helping a handicapped student this semester, going on a 3rd week. And then social media, web, graphics, and interns are needed for both CIS and Transform Rockford both. So if you're interested in becoming an intern, you get 1 credit per 75 hours. And I believe I've had 1 person already email me last week. I've not gotten back to you yet, so whoever that person was. So I will be gathering names. I am gathering names of those interested in internships. So it's fun. Vanita just got through with an internship, right, at Winnebago County. And she did work for Transform Rockford as well as an intern in social media and did a great job. And so it's a good experience while you're taking your courses here on campus to apply it some way. And I always recommend students to do it through volunteerism, whether it be at a high school, middle school, a local non-for-profit, to where you can help them with their network or whatever it is they need help with their website, whatever it is, installing printers, setting up computers. It's all a good experience, right? And it's great on your resume too, it really is. A lot of internships today, though, are paid, by the way. The ones posted here are not paid, but majority of internships are paid. The other internships that's on here I forgot to mention, it's not on the page there, but 95.3, the country station, is also looking for interns on like office stuff, like Word and Excel, social media, and graphic design. They're looking for interns for the morning show and afternoon show. So if you're interested, you can go to meyervc.org, and on that post there is an email. You can email the DJ directly if you're interested, and that's 95.3 The Bull. Yeah, I almost said that like a DJ almost. Sounded pretty good. I don't think I did. All right, Hour of Code at RVC. We've already went over that. That's rvchourofcode.com. That was the event in December. Now, Vanita was in there, I believe, weren't you? Yeah, you're over there towards the right. Yeah, I think I had 5 or 6 RVC students volunteer to help me that day. It was awesome. I did give them a giveaway, and I think that was it. But it was all day. It was like 8 in the morning till noon, I believe, right? So, but it was a lot of fun. Everybody had a good time. So that. Week 2, I've already talked about the reading for week 2. If you haven't already begun, it is chapter 1 reading. And you click on the chapter 1 link, it'll take you right there to the online reading. And you can download a PDF if you want to or not. The review questions, I believe, are gone now out of your view on Eagle. I believe those are gone. So introduction to networking. Let's get right into it. So we're going to look at some advantages of networking relative to standalone computing. We'll look at also what client and servers mean, distinguish the differences between the two. Peer-to-peer networking we'll look at as well. And we'll look at some common elements between client-server architecture. We'll look at several different specific uses for a network and some of the certifications available. Some of you might be interested in some certifications. We do offer some here on campus. We don't offer it. We just host it at the testing center where you can take certification like Network Plus, which will be an offshoot of this class. It's not a Cisco or a Microsoft certification. It's just a middle-of-the-road Network Plus certification, which I highly recommend. And what that means is you can get a job with that behind your belt on a resume. And then businesses a lot of times will send you for the further training that you might need, like maybe pay for your classes here for Cisco or something, or pay for Microsoft certification exam or something. That's what I recommend. Not that you can't pay for it yourself, but ideally, if you can have a business pay for it for you through their educational funding or whatever, hey, it saves you some money, right? And so that's what I recommend to do. We'll also look at some skills and specializations to help you as a network professional. So what is a network and why use a network? I'm glad you asked. Networks are a group of computers or devices, and they've added devices in the last few years because of mobile, iPads, iPhones, Droids, Windows devices, and they're all connected by some type of transmission media. That could be wired media, like in the back of the room in a few weeks, we'll be creating like the crossover cable and straight through cable. Could be wireless, could be fiber, could be satellite, point to point, could be Bluetooth, could be infrared. A whole bunch of different ways to connect devices. So transmission media and also coaxial, like you have at home going into your TV if you have Comcast or Xfinity. That's also transmission media as well. So standalone computer, this basically is just like many of you have at home, just by itself, sitting there, local software, local data, not really connected to other computers per se, but it's a standalone. You'll see these also in public kiosk, Kinko's, libraries, but a lot of those are standalone, but they're quasi-networked as well together. Advantages of networks over standalone is because you're sharing data on a network, you basically have one shared resource everybody can use. So if one of the computers go down in a network, no big deal. Replace that computer, data's still there because it's all on the server, and we'll talk about that later. So that's a benefit. Downside to standalone is the fact that if a standalone computer dies and it crashes, you've got to get another one. And hopefully, if you didn't back up the data, well, if you didn't back up the data, then you're shot in the foot. But if you did back up the data, at least you can restore it. And we'll talk about backups this semester as well, the importance of that. And also central network management. Basically, you can manage your network from any location, either mobile device. You can be on the beach in Venice. You can be in air. You can be underwater if you have the right contraption and right technology, and control your network and manage your network. And we'll use tools this semester that'll show you how to do that mobily and wirelessly. So models that vary as far as networks go, the positioning of where computers are at, and you'll kind of see that tonight when you guys do your lab. You'll position your computers differently in your network, depending on your group. Controls over shared resources. Who's going to see what? When are they going to see it? Why do they need to see it? All those questions need to be asked. Minimal. There's two schools of thoughts when it comes to resources: minimal security or maximum security. Minimal meaning you trust everybody and you just, trust your people not to get into things they shouldn't get into. Or maximum security, meaning they don't see folders they don't need to see. They can't have access to things they don't need to have access to. It'd be kind of like the military on a need-to-know basis. They're going to have access to that information. Two types of network models. You've got peer-to-peer and client-server. And you've used both of these. All of us have used both of these, even though you might not think you have. You have. So, peer-to-peer basically is equal authority. You've got individual shared resources. It'd be two computers, to be simple, you and your neighbor connected to each other to share folders. We'll say that as an example, right? Where you can share what you want to that person, but you neither one have any more authority than the other person. You're both on the equal footing on a peer-to-peer network. You can prevent people from accessing things. Traditional model is two or more general computers connected together, capable of sending information back and forth. There's also peer-to-peer software you might have heard of. Got Nella, Kazaa, LimeWire, a whole plethora of different peer-to-peer type of softwares out there that allow millions of computers to connect together to share resources. And sometimes those resources are not the best resources to share. Could be illegal in nature, maybe. But it is a peer-to-peer technology, peer-to-peer where you're sharing information that you want to share with the world. So here's an example of three computers on a peer-to-peer network, and they're just sharing documents, sharing files, sharing work with one another. Advantages: it's real simple to set up, and peer-to-peers can be set up in a wired or wireless configuration. It's less expensive to set up. Disadvantages: it's not flexible. It's no growth involved. It's not necessarily secure because you literally have to leave yourself open for folks to connect to you. And then it's not practical for large installations because an example would be if Bob was gone tomorrow and was sick and he was the one that had the database on his computer and his computer isn't on and we can't log into it, then we're pretty much shot in the foot. And so that's one disadvantage. Multiple other ones, but resource sharing, user responsibility. So if Bob gets mad at you, he can stop the resource from being shared to you. Not centrally controlled, potential variations, security issues, as I already mentioned, somebody being gone. Environments it's good for, though, is small offices, home use. And I've already mentioned some of the larger networks out there that have clients that you can download. Got Nella, Freenet, Napster, BitTorrent. BitTorrent's one of the new ones on the block. And BitTorrent's actually used by Microsoft, it's used by Apple. And all BitTorrent does is when you download files from their servers, it splits it up into millions of pieces and then brings it back down to you on the client side. And that's a benefit of having a peer-to-peer. And the bits and pieces are scattered all through over different networks and different servers throughout the world. So client server. A client server has a central server in the mix. It facilitates communication, resource sharing. The clients are personal computers. They could also be mobile devices as well. Could be in this mix. They're also known maybe as workstations. And central resource sharing is controlled by the server, like data storage. Everybody has their own network drive generally. You share data generally from a network drive. You store critical data on a network drive, nothing critical on your local, because if your local crashes, it's not backed up on a nightly basis generally, and that data is gone. So in my world as a programmer, we do what's called source control, to where we commit our changes every day to a network folder or network drive using source control, and it's backed up on a nightly basis, like around midnight. And so if my computer was to go kapoosh tomorrow or tonight, no big deal. Just get a new computer with the same software and download the latest version from source control and be up and going. So there's no direct sharing of client resources though in this one, like there is in peer-to-peer. So differences in peer-to-peer really is you're not relying upon clients for any function in a client-server architecture. So the roles of computers, you've got server roles, you've got client roles. The clients run the local apps like Word, Excel, PowerPoint, Access, a database of whatever type the database uses in that area. Data stored locally. You shared applications, like there are applications that you can run off a server that doesn't need any or very little resources on the client to run. In fact, a lot of times all it needs on the client side is a key that you have access to that application. And so there's really no install on the client side except clicking a link on a website or something and it running on your side. Clients are used as an intermediary device, so they're just passing data from one to the other, but it should not be used and is not generally used as storage for data. And then communication is routers and switches. And I'll walk over here real quick to show you some of those real quick. So we have here in a case mod here, in this baker's rack, some switches. And at the top of the case here in the corner, that blue one, that is our router for the room. And this one really has been decommissioned. Most of ours now are in the back three baker's racks back there. And the reason they call them baker's racks is they usually have a rack where you can slide in the switches or servers. And the way it works in here is it comes into this router here. And on the back of the router there is two Cat5 cables, or actually three Cat5 cables. And one of the Cat5 cables goes into the back of this box, and there's another one that's tied to fiber optic, which goes under the floor into the IT lab over in here, the IT room, that whole host of servers. And so in this room, everything is connected to switches, and then one router. And then our main server in this room is in the other Cisco lab. So configuration-wise, you've got in the middle there, and this is just for modeling. This isn't how it would actually look. There's no power cables or nothing. But you've got your connectivity device. We'll say it's a switch there in the middle. All the computers and printers and servers are connected to that device to allow everybody to talk to one another. Sharing data, printing, whatever. Just like in this room, if you're connected to it anyway, you can print to this printer here that's network enabled, and runs over the network. And so this is resource sharing, and the resources are generally all coming through the server there on the upper right. And so files, databases will be the main two that companies use, are going to be stored on that server. Also, your personal files will be generally stored on a personal network drive. And you're given anywhere from 5 megs up to 5 gigs, depending on the driver space that the network admin gives you. So there are some misnomers, I guess, coming into class from some students, maybe not you. And if this is an intro class, so you're not expected to know this. Operating systems. What do you guys use for operating systems at home right now?
A whole bunch of, I use Windows 10.
Windows 10. Okay, great. Anybody else? 10. Oh, you use a Mac. That's right. Mac OS. 10. 10. 7.
Just OS, iOS.
Okay. 10. And 10. All right. So most of you are Windows 10 users. Great operating system. But network operating systems are different than Windows operating systems that you're used to using, which are client-based. Network operating systems are actually designed to run a network. And so you're going to have different bells and whistles, it's going to be beefier basically. It's going to use more memory and be able to allocate resources better, manage other clients. And so let's go look at the list. It manages client data and resources, ensures authorized user access through a program on a Windows server called Active Directory. And it controls user file access through Active Directory as well. Restricts user network access through Active Directory, and then dictates computer communication rules, and that's going to be basically through Active Directory and in tandem with switches on the network that you've configured. And it also can supply applications to a client, or clients plural. Some server examples, you've got Unix, Linux. Linux is big in the web world. I teach PHP, and 79% of PHP web servers are Linux, and around 79-80% of web servers in general on the web are Linux-based web servers. And we'll have opportunity this semester to play with Linux 1 week. We look at Ubuntu, I believe, and if you've never played with Linux, you get to do that, and it's the most popular client OS and server OS is Ubuntu. And Red Hat's another one. Microsoft Server. All the way up through 2000, and I think we're at 14, 15, coming into 16 now. Mac OS server. Mac OS used to have an actual, not just operating system, network operating system. They used to have unique hardware too, up till about 4 or 5 years ago, and they got rid of that. But Microsoft does have unique hardware for servers as well that fit in these Baker's rack, about 30 inches deep, about 1.5 inches high. And that's it. A lot of them don't have any CD-ROM drives. They'll have in the back maybe USB 3 ports. They'll have a fiber port, 2 or 3 fans, maybe up to 7, 8, 10 hard drives can connect to them, and memory modules maybe up into the terabytes depending on the server you get. And so much different configuration than what you're used to on a client OS. But it's managing literally and sometimes thousands of clients, to be realistic. Some less than others. So server relative to clients, I've already mentioned some of these, can have more memory for sure, all right? More processing power, like some of the servers in our IT lab have 18, 19 processors built into it. Literally when you open it up, you literally see them stacked up one on top of the other. Multiple storage capacity. They have what's called RAID 5, which we'll talk a little bit about this semester. Basically what that means is if one hard drive fails, the other ones take up the slack and it keeps going. They also have RAID when it comes to fans, multiple fans in the server as well. That way if one fan dies, they can literally hot swap, pull it out, put another one in while the server's still running, and don't even have to shut them down anymore. About 3 years ago, I got to meet when Apple still had their network devices, or server devices for OS, network operating system. The engineer at Apple, Keith Mountain was his name, and he developed and patented, and Microsoft uses it now, the RAID fan technology. Up to that point, when a server the fan would die and go out, which they do over time because they're literally running 24/7. You'd have to shut the server down, take the fan out, replace it, turn it back on. Well, he developed a technology to where you didn't have to do that anymore. It would alert whoever in the IT that you had it configured to, hey, fan and so server's down. They would go over, flip a switch on the back of the unit, like a little metal switch, pull out the fan that was dead, put a new one in, flip it back in business. Pretty awesome. And he created that right at the tail end of Apple decommissioning their servers. But Microsoft uses that now on all of their Blade servers now too. Dell is a big server manufacturer, HP. I would say between the two, though, in my estimation, Dell is up there probably superseding HP when it comes to servers for businesses. They're huge, and you've heard of Dell on the client side for your guys' computers, but they sell a lot more, make more money anyway in the business side when it comes to servers. As you can imagine, they're much more expensive. A cheap server, when I'm saying cheap, for like a company of 250, 300 people, 250, 300 computers, it's going to cost, once configured with the software and everything, roughly around 8 to 10 grand once you set everything up, can connect to it. And so, your normal PC at home or even Mac, maxed out might be 2,000, maybe, and that's pushing it. It's putting everything in it, right? And so much different cost, but it's also much different as far as what it handles. Now, because of that, the last point says a disadvantage of peer-to-peer is it's complex in design and maintenance because things can go wrong. There's a lot more components, a lot more features that work, but also can't work, and you have to have somebody fix them. And so there are some disadvantages. Advantages relative to peer-to-peer, user credentials in one place, and this is awesome. You can use what's called roaming authentication, meaning say you have an assigned computer at work. If you move to another computer, it would download your profile to that computer and all the apps that you run and rights that you have to that computer. And you don't have such a creature in just individual client OSs. Also, you can share resources centrally in the network client architecture. Central problem solving and monitoring. We'll look at some monitoring tools this semester where we can monitor the entire network globally, literally from a tablet or a laptop or a phone, and determine the health of that network and troubleshoot it with really cool monitoring tools. Diagnostic correcting capabilities. User response time is usually higher because the client isn't bogged down with sharing data. They're doing what they're supposed to be doing, which is just running applications. That's it. All the data stuff and all the files are stored on a network. Because if you've ever had a computer that's getting low on hard drive space, which we probably all have, if you haven't, you will maybe someday. What happens when your hard drive space, anybody had that happen when your hard drive space starts going out on your computer? Or it's getting really low? You ever had that happen? Yeah, what happens on your phone? What happens?
Well, if I need to download another app, I have to find something to delete.
Exactly. And a lot of times, too, on a computer and even on a phone, when your hard drive starts getting low in space, it begins getting slower in doing stuff. So same thing with optimization. Buying a client server is going to give you more resource on the client side. It's also efficient on processing larger networks. And so, like I said, 250, 300 and up, or even 100 people, 50 people, much more efficient than a peer-to-peer. And it's much more scalable. You can grow it and add to it as time goes on. And it's very popular in medium to large organizations. Mediums, 50 people, 25 people, whatever. You probably wouldn't want a peer-to-peer. Personally, I wouldn't want a peer-to-peer past 3 to 4 people. I'd want a network past that, just because you can buy network operating software and maybe not have all the bells and whistles you would have. The 10 grand price tag I gave you earlier, maybe set it up for 3 or 4 grand. But if you're talking 20 people, it's worth it because they're. So local area networks, more terms here. Local area networks is a network confined to a relatively small space. This room would be considered a local area network, and even really this building could be considered a local area network. So all the rooms in this building have these little gray boxes that basically connect to all the PCs in here, and then a line from the box goes into the server room. But they're also daisy chained between room and room. That way, like since this one's the closest to IT server room, it's the first one in the chain. And then you've got this classroom over here. There's a line that goes from this one to that one, and that one all the way around the building. But even though it's small in here, when you add all the computers together in the entire building, quite large. But we'll talk more about that in a second. But LANs really became popular in the 80s because that's when computer technology was actually there to have a LAN. Before that, we didn't have it. So my first mobile computer was 1987, 88. When I mean mobile, it was 75 pounds. And it was about this tall, about that wide. It was an IBM. You folded out the keyboard and had a little 5 1/4 inch monochrome screen, two 5 1/4 inch floppy. It had 2 megs of RAM and a 20 meg hard drive. It was screaming. Yeah. And everything, there was no Windows. Everything was DOS and black screens. And so I'm a big history buff when it comes to computers. And one of these days when I retire, hopefully, be able to, is I'd like to have a museum of both PCs and Macs both, because I have some old stuff. In fact, if I'm going to invite another teacher that did this for me last semester, Paul Newell. I don't know if you guys have had him as a teacher. He's an adjunct here. He's been around longer than I have, but he's kept all this stuff over the years. And he did a thing last semester for my Cocoa Heads. I'm going to try to have him again this semester, where he did the history of technology. And he brought all of his gadgets. He had an old slide rule he had in college. He brought in his first camera, his first mobile cell phone that still works that he used in his car, a bag phone, his first calculator, then his first laptop, and then all the way to desktop. And so, but anyway, the 80s though was the very first time, because that's whenever we had the technology and the Microsoft and the Apple started coming into play. IBM's were already here. They had big machinery, IBM's did, for corporate and government. And then today, a much larger, more complex client-server architecture exists. Then we have from LAN to MAN. MAN is Metropolitan Area Network, and it's a network that extends beyond building boundaries. So I talked about earlier this being a LAN here in this building. Well, we've got multiple buildings here on campus. We've got this building, we've got the JCSM, we've got CL2, we've got the ERC, we've got Student Center, we've got the the maintenance and security over here. All of those would be considered a MAN, connected one to the other. You say, how do they connect to one another? I'm glad you asked. You guys are real talkative. Anyway, there's these tunnels between the building, believe it or not, that literally a golf cart can run through with these tunnels between all the buildings. And there's fiber that runs in these tunnels that connects this building to that building, this building to all the other buildings on campus. And on the building side, when it first gets to that building, the first connection device is fiber. And it goes from fiber to a little box like this in the basement, and then goes from there and just builds its way up throughout the entire building. So it's larger than LAN, connects clients and servers on multiple buildings. Then you go from LAN to MAN. Now a WAN is basically the Stenstrom Center. Anybody taking classes there, the Stenstrom Center? Or been there? You been to the Stenstrom Center? Okay. Well, the Stenstrom Center would be a WAN connection, because it's going to be using either a direct line from the telephone company, or it can be point-to-point technology through satellite, or it could be underground cable. The way we do is this direct line, a T3 line from this campus directly to the Stenstrom Center through telephone poles, and I'm sure there's some underground somewhere. But anyway, that's how it works here. But the way I tell students to know the difference between LANs, MANs, and WANs, LANs is in the building or house that you're in right now. That would be anything in that vicinity would be a LAN, a local area network. If you're connecting multiple buildings, that would be a MAN. If you're connecting on the same location, multiple buildings on the same location, same geographic land location, like on this plot of land. But if you're talking geographic beyond, like miles away, or maybe even blocks away, you have to connect with some internet connected device, whether it be cable, whether it be satellite, whatever. So where you're using the internet to connect two networks together, that's a WAN connection, okay? And you usually see the little lightning bolt, like on the screen here, to tell you that's what it is. It's a WAN connection. I don't like that white. Let me get a little different color here. So right there is a WAN connection. I still don't like that one. We'll do a different color. How about blue? I think blue's going to be better. There we go. So that's yellow is not a good color for that slide, but it's yellow. And so lightning bolt WAN connecting two MANs together to make a WAN. Now you'll notice something on the screen here. I'll see if I can blow it up here for us. Okay, so one of the things I want you to notice is router, just those two only. Okay, the two routers in this WAN connection is the first line of defense coming in to that network, okay? Like that box in this room is first line of defense coming in here. A router is configured by rules to let stuff in and to keep stuff out, all right, that don't need to go out. And so basically a router is going to be before a switch, and you say, what's the difference? Router is generally a configured device for, let's say you have a website you've hosted on your business, and you have, say, Xfinity, which is Xfinity Business or something plan. They're going to give you like 3 IP addresses for your business to use, and you get a domain. You buy it maybe through GoDaddy. You tell GoDaddy, here's my external IP address that Xfinity's given me. They plug that in. You tell your router, when it sees that IP address, you route it to, let's see here, we'll find something on this side over here. We'll say that one right there. We'll say this is the web server. You route it to that IP address when you see that external IP address. Those rules are found in the router, this right here, to point it to that local server when it comes from the outside world. abc.com might be your website. Hits your router, it sees that external IP address and routes it to your web server. Now you can do this at home too with your wireless router. You can set up a web server on like a DMZ port, and you can, if you want to do that, I have the steps on the website, actually on pct110. I have it buried in there. I can show you where it's at. And you can set your own Wi-Fi or your own web server up at home with the same technology using your Wi-Fi router at home. Because your Wi-Fi router at home is a smart device as well. You might not have configured it at all, but it was already configured for you when you took it out of the box. You might have just set the password, change the SSID, and that's it. Set the security on it. But if you go to the administration part of that router, you'll see a whole bunch of check boxes of things that are blocked or allowed or blocked, either one. And if you don't know what you're doing, I wouldn't just go in and check anything, because you could block everything from working. And so, so with this, the reason I want to blow that up was to highlight the routers are the first line of defense coming from the internet into the building or into your house, right? And then outside of that would be your switches. Now at home, you can buy like these little 4, 5, 6, 8, 10 port Linksys just boxes. They don't call them switches, they call them just hubs at home for home uses. And basically it's just ports on the back of a 4 or 5 Ethernet ports you plug in, where you can share network connectivity from your home router. Your home router on your Wi-Fi will generally have 3 or 4 ports in it as well, and I recommend using that. So let's say if you have a gaming system hardwired into that, if you have a media system at home like a Roku box, or you have a Mac Mini, or you have any type of Apple TV, you connect it hardwired into your router. It'd be much better connectivity than Wi-Fi. But the first line of defense is router, and then from that is your switches. And switches are also configured, and we teach switch configuration here in college in the Cisco class. And switch configuration also can tell what IP address ranges are on the switch, what's the server IP address, and that way not just any IP address can hit that switch. Only those configured ranges can. Like in here, we have a certain range. It's like a 172.0.2. Whatever that is allowable on those switches, and that's it. Nothing else is allowed. And that does add some security when it comes to hackers coming into your network, keeping hackers. So, WANs, 2 or more geographical regions connecting LANs or MANs. Technically, it could be connecting LANs or MANs, but more than likely it's going to be connecting, in most situations, LANs. Because most businesses don't have complex buildings like we do. So for universities, it's always going to be a WAN connection to a MAN. Businesses, for the most part, are going to be WAN connection to LANs for individual businesses, connecting one to the other. An example would be Pepsi, Coke, Walmart. Generally, Walmart they're scattered miles apart. Same with Pepsi plants or Coke plants. But they're going to have a local LAN on those environments connected to a WAN connection to the mothership, wherever that's at. Like Microsoft mothership is Seattle, Walmart, Bentonville, Arkansas. And so depending on the company, is going to depend upon where that mothership is, where they're going to connect that WAN connection to. And believe it or not, a lot of these companies like Walmart, Sears, JCPenney, when the people log in every day when they go to work, they're not logging into the local LAN network. They're logging into wherever their mothership is, that LAN, every day. And when they clock in, the data is stored there, not here. And it's connected through a WAN connection. Benefit, or I guess a positive of the Twin Towers being hit, one of the positives, a lot of positive stories came out of it, but one of the positive stories that came out of it was, people were concerned that all the data was lost, and a lot of stock exchange folks, finance folks in that building. Anyway, every business that was in that building had all their data was stored off-site on a daily basis, was transacted off-site through WAN connection. I was in the North Tower February of that year at Windows of the World, which was at the very top floor overlooking New York. And I remember the day that 9/11 happened. I was teaching high school, and everybody remembers where you were that day. But one of the discussions we had after that was not only the eeriness of being there months before, but we started talking about, the IT guy and I started talking about data, and we knew some people in New York, and they told us everything was fine, no data was lost, because everything was on a WAN connection backed up on a nightly basis. So people didn't lose their whole life savings and things, and businesses didn't go under because of that. So here's a screenshot of LANs, MANs, and WANs, what it could look like. A little bit cleaner screen than the last one as far as how it looks. So on the right side, you have over there, we'll say it's a LAN. Left side's a LAN, and it's connected in between with that internet connection, which is the WAN connection. First line defense, like on any network, like I already mentioned, is your router. And then from your router, you're going to have multiple switches to connect your computers, your printers, smartphone devices, tablets, whatever. Wi-Fi access points that aren't in here, that could also be and would be connected as well. So ClientServer Architects, some elements common to them is a network computer requesting resources or service from another computer. The client workstation has a human user I mean, maybe it would be an alien user. I don't know why the book said, why my slide says human user, but it's a human user. Maybe a robot user today, I guess it could be. Client workstation has a human user, and client software is installed on a workstation. And we've talked, the plethora of different softwares could be installed. Server has its own network operating system. It also manages all the shared resources on the client or from the clients, as far as data, databases, data, authentication, all done on the server. Workstations may or may not be connected to a network. In fact, education, there's a lot of colleges that, depending on the division or department, might still have software running that cannot run on Windows 10 or Windows 7 or Windows 8 or Windows XP or maybe even Windows 95. It might be still running on Windows 3.1 way back when, because the software that was developed for, say, a research project might be the only thing that really works for what they do. And so medical is the same way. You'll have a lot of older computers standalone that run certain things, certain configurations. So standalone computers are still around, believe it or not, in factories, manufacturing, education, and healthcare. Anybody know of one that you know, maybe where you work or you have worked, that had an old PC or an old, maybe it was an old Linux machine or old Unix machine somewhere in their business that it was still used once a month or once a year? Anybody have anything like that, a story?
Not recently, but they used to have the digitals. Those little, they didn't call them they called them microcomputers.
Okay.
They were on little wheels and they ran chemistry analyzers.
Okay.
And then we would transfer the data to the network in the hospital or wherever.
Right.
But they were not connected.
We're not connected.
Connected to the.
So you had to take the data from that, massage it, and put it
Take
in.
the data to the to the doctor.
Right.
We had to do that personally.
You had to manually do that.
Because it just
Yeah.
worked well.
Yeah, and I'm glad you shared that, because a lot of medical companies, believe it or not, hospitals, the hospitals themselves are fairly still, not that they're not upgrading, but they're still, as far as the systems go, the outer clinics are generally more updated system-wise than the hospitals.
They just don't want, it's like banking, if something's working well.
Yeah, they don't mess with
It's
it.
too much, you don't wanna mess with it.
No, you don't want to mess
As
with
long
it.
as everyone's happy, but.
Exactly.
Now it is changing with Epic, there's Epic and then there's another two main data systems for hospitals and labs. And
Right,
everything.
Epic. Yeah.
Epic in Madison.
Yeah.
One of them.
Mhm.
And
Yeah,
then
it's
there's
big.
Cerner is in Kansas City.
Yep.
They're
Mhm.
huge. They just got a huge multi-billion-dollar contract.
Yep.
with
Turner and Epic's the top two. Yep.
Well,
Yep.
that's all changed, but that wasn't that long ago.
Yeah. Well, thanks for sharing that. So I know there's a lot of companies that still have them. You'll probably walk into one in your lifetime in networking. Let's talk about some hardware now. NIC card is a network device, a network interface card. Both desktops like you guys have in front of you, laptops, phones, tablets, all have, like even my iPad has a NIC card. You can't see it, but it's built in to the device. It's a wireless device, wireless NIC card. It basically allows the computer to connect to the network. In my iPad's case, it connects to the wireless network. On my Mac, I can connect to wireless or wired. On your computer, you can connect to wired in the classroom. Network operating system, or it's just called NOS, the NOS of the network. It's a server software, which I've already went over the different flavors of that. This enables servers to manage data, enables user groups, security, applications, and other network functions. I mentioned this the first of class. Active Directory is probably the main piece within networking operating system that you'll need to really learn a lot about. We have a section in Windows that Stephanie teaches on Windows Server where it goes over Active Directory. I mean, literally, when you go to a store, like say if you go to Barnes or anywhere and look for Active Directory, it's literally a Bible, like that thick of Active Directory configurations. But you can do a lot with Active Directory, and you can save a lot of time on a network admin side with Active Directory, because it allows you to globally set rules for certain groups. So if everybody in here, maybe you guys are in marketing, you guys are in sales, if I was a network admin and I was configuring Active Directory for you, I could set certain rules for my marketing, certain rules for my sales group, to where you guys can't use each other's printers, you can't see each other's files, But I can even set times of when you can or can't get into the network too. So I can set time frame of, say, you can only get in from 8 to 5 and that's it, Monday through Friday. If it needs to be done otherwise, it has to be overridden. Here's what a NIC card looks like. You'll notice it's plugged into a motherboard, and this motherboard has multiple slots for cards. It could be a network card, could be a video card, could be a sound card, could be a scanner card, whole bunch of different cards that can be purchased. And then you've got your Cat5 cable plugged into the NIC card. Now, laptops generally have embedded NICs, which we'll talk about this semester. That's different than this one because just for room's sake, you can't fit something like this in. This is from a desktop unit. And then most of your desktop units even today have little, basically what it looks like is, here's the motherboard here. It just looks like a little square on the edge of the motherboard, and that's it. And that's all it looks like. That's all only room it takes. It pretty much looks like, as far as size-wise, about the size of this right here on the motherboard, and that's it. And just enough room to plug it in, that's it. And it's soldered on the motherboard. If those go, that's when you need to replace something like this on a desktop that you see here, a larger card. We'll actually have a lab this semester where you'll get to uninstall and install a NIC card. So host computer enables network resources. A node, I always tell students, it doesn't say it on this slide, but I always tell students the first node of your network, I think in week 11 we do a troubleshooting lab, week 12 actually, we do a troubleshooting lab where you guys get a chance to be on call in a network IT room, and you're going to be able to serve both as a person having problems with their computer and a person troubleshooting that problem. But anyway, the first node on a network is not a client, it's a person, because you'll find out with that lab, the health of your network really is determined greatly upon the health of the employees connected to that network as far as technical health, their knowledge base, and maybe even their mental state, okay? Maybe even their social state will determine a lot with that communication with IT. So you've got person, you've got client, you've got server, and other devices that we all know is out there now. And then it communicates over a network, like we've talked about tonight. In this classroom, we have Ethernet to fiber to the server room. We also have in here Wi-Fi that could be connected if you brought a device to connect to it. All over campus, multiple different SSIDs to connect to. And then the connectivity device itself basically allows multiple parts of that network to communicate and exchange data. Now that data could be just internet and that's it, to get on the internet, but it could be data like files that you can access on your personal drive, database, programs, movies, sound. The segment of a network is just a group of nodes, so we could say actually this building could be split up into 3 segments, 1 segment per floor, we could say. All right. We could even go more granular and say every classroom is a segment. We could do that even. Or you could even go larger and say the building, just the building on these campuses are a segment. So segments are just a group of nodes using the same communication channel of traffic. Backbone is referring to what your network talks on. Here's an example of backbone in this building. You've got Ethernet backbone, we've got fiber backbone, we also have wireless backbone in the building, all right? And that will be your backbone, what it falls upon. First majority backbone in this building would be Ethernet. Secondary is your fiber, which usually connects server to server, box to box, and then Wi-Fi connecting guests, students, faculty that want to connect their personal devices for the most part to the network. And then topology, we're going to do that in just a second, or actually we're going to talk about in just a second, the different topologies of a network. You've got how the computer is laid out, how the network is laid out. You've got ring, bus, star, or hybrid. So in this example here, we have a backbone, a of the network, we'll say, is totally Cat5 on this one. From server to switch to client to router, all Cat5. So these are the common types of ways you can set a network up and to communicate. Now we'll start with the oldest, the bus one on the upper left. You'll notice it looks kind of like a coaxial cable because it is a coaxial cable. In fact, the NIC cards for this fit a coaxial cable like you have in your cable TV at home. Really fast, just as fast as your Cat5 connection, but really expensive. So, you know, the cost of creating a coaxial cable is about 10 times more than creating the same length Ethernet cable, because you've got your center kind of copper type of wire, and then you've got your outside of that a plastic, and then a metal sheath, and then another plastic, and then finally rubber type of material on top of that, rubber plastic type of material. So much more expensive, but it works fine. It's very efficient, but expensive. And also too, the bus topology had terminators they had to have at the end of the network to terminate, which you don't have to have now with Ethernet. Then the bottom left was the next iteration of networks that came out, which was a ring topology, which still used coaxial originally. And you'll notice they're all kind of daisy chained together in a circle. Banking facilities, military, a lot of redundancy in this. In fact, a lot of ring topologies have two NIC cards in it, one for in, one for out. Okay, but the data gets there. It's important when you have to make sure data gets there. New York Stock Exchange, healthcare, banking facilities, all are going to have ring topologies in their networks. And again, you do have redundancy. The way it works with ring is this. You've got, if I'm taking some data on this PC here, and I'm wanting to bring it over to this one here, what's going to happen on a ring topology is, as it's going across the network, two nodes are going to have the same duplicate data as it goes across the network. So say if it's a 5 meg file, it's going to be 5 megs here, 5 megs here, and then when I'm done with this one, I go to this one drops it, now it's 5 megs here and 5 megs here, until it finally gets there. So that's 15 megs of files that it duplicates. Once it gets here successfully though, on the last one where it's supposed to go, the other ones are deleted finally, after it makes sure it gets there in the network. And we'll actually look at a video next week of how that all works, how those data files get there, and how the network knows it. And then if it loses a data file, it can ask for the one originally where it was sent. There's smart technology. So here's some other terminology. We've got protocol, data packets, addressing, transmission media. On protocol, it's basically an example protocol would be like TCP/IP protocol, which we'll learn about this semester. Transport control protocol, and IP address. Data packets, how things go between two nodes. What are you conversing between the two nodes? Are you sending data? What type of data? Is it video? Is it audio? Is it text? And addressing, every node has unique addresses. So what I mean by that is switches have a unique network address. Your NIC card has a unique address. Your IP address has a unique address on the network. And you'll learn all about that this semester. And then transmission media, all different types of transmission media. You got your Cat5, you got your fiber, you got your Wi-Fi, you got your satellite. You have USB can be even transmission media, USB 3, Bluetooth, RFID, whole bunch of different types of media. Here's a slide of some different types of transmission media. You've got at the top coaxial, which is old school, but you still have in your house for cable. And then shielded twisted pair, that's what we're going to do in here tonight, or not tonight. You guys are like, tonight? No, it's till midnight. Week 5. Shielded twisted pair, much cheaper, but same data throughput and everything. And the way it works on a twisted pair is the more twist you have, the better the data attenuation, and the less data drops on a twisted pair. but much cheaper to make. And then fiber optic, more expensive than all three so far. Fiber optic generally has a glass fiber, or it can have a high plastic fiber as well, high cost plastic. Most of the time glass, and these can be oceanic fiber optic. It could be like, for instance, AT&T. Any new lines that they run is all fiber underground, usually 8 to 10 feet underground. And you might have seen trucks around your area putting in fiber. If it's a new subdivision, it's all fiber. And then radio waves. We did have a number. They were moved. I don't know if you guys remember in the WTC, when you leave the building on the right, the satellite farm that was out there. And that was used for point-to-point technology with Stenstrom, other businesses, where basically it was set up to where faculty or anybody that we wanted could teach here, and we could push it out, and then vice versa. Folks could push stuff here as well with satellite radio waves. So how networks are used, basically you've got functions are provided by the network. The most visible would be email, which everybody uses. And on the email, just a note on that, 98% of emails are blocked on most business email servers because of being junk mail. All right, only 2 to 3% are actually valid mails coming in, and that's pretty mind-boggling. And so the whole email blocking business, and one of the bigger ones you've got a couple of them out there, but you've got Barracuda is a big one that has hardware devices for blocking, Cisco, and those are the two main ones. We'll talk more about that this semester. But other vital services, you've got print services, internet services, voice, video. I mean, every business is wanting to get on video now. And video is a hog when it comes to network. A hog. You can't do it on Wi-Fi hardly. We've been trying this semester, believe me. The only way we could end up doing the student connecting to Dester is cellular iPad. That way it's not dependent upon any Wi-Fi whatsoever. Because it was fine before students came into class, but when you get 40 students connect to Wi-Fi, it drops real quick. The speed drops real quick. You know, say, why do they need to be on Wi-Fi for? Exactly, that's what I say. Why do they need to be on Wi-Fi for? You know, everybody's got to be on Wi-Fi, right? File services, file server to back up data and to store data. Print services to print, and then access services. This would be basically how you allow people to access your computers, or do you allow them at all to access your computers remotely? That's a decision you have to make as an IT department. Do you want to provide services to the users to where you can allow external users to come into the network to connect? That's a decision also. That falls under access services. Communication services, I'll mention on this slide. Email, you're familiar with that one. Mail server, right? Just sending mail, receiving mail, server. And on this slide, I'll mention when it comes to email, the fact that it can route messages according to rules that are set up. That's where the junk mail comes in. You can set up rules. Block domains. You can provide a web-based client, internet web browser for your clients to connect to their mail server. Internet services, you could have a web server on your site or not. Management services, you could centrally control your management, and there are companies basically that do this, by the way, third party that people hire to come in and control their whole network remotely, and they do everything. They do backups, they do configurations, they do updates, all remotely. And for a lot of businesses, it's cheaper than hiring a fleet of network folks to do it for them, where they can hire it out to get done remotely. Entree here in town is a company that does that, by the way, does activity for companies. Other important management services. On this one, I'll mention a couple. Asset management. That is basically, there's a tool called, I'll write it up here. I'll put it on the board so you can make note of it. It's a software, totally free to download. Spiceworks.com. Allows you to install on any computer, and within 24 hours it monitors and gets all the connected devices on your network for you. And then all you have to do is go in there and upload PDF files of when you bought it, warranty. It even has a built-in ticketing system. It's really cool. So you can even do it at home and play with it. You know, if you have 3 or 4 computers on your Wi-Fi network, you can see what everybody's connecting to your network with. Or maybe people that are connecting you didn't think were connecting to your network. You can find that out too, probably. So becoming a network professional, I'll end on this one, and then we're going to go into the lab. So the job market for network professionals and networking is huge, like Donald Trump would say. It's huge. There's many postings all over the web, both locally, regionally, nationally, for skilled network professionals, or even folks that are novices like yourself that just want to get into the field to get some experience. The expert levels are varying upon the job, and to prepare to enter the job market, I suggest a couple things. I've already mentioned earlier one of them, and it's not on the slide here, but volunteerism is good to local community businesses, volunteering your time and your knowledge of what you do know, what you're learning this semester in the school. You can apply it immediately. That's a great thing to prepare the job market. It also looks good on your resume that you're willing to learn, you're willing to stretch yourself, you're willing to give. Also mastering the technologies, and the best way to master it is to do it. And so by volunteering or getting an internship or some type of part-time job is helpful. And then you'll figure out eventually what your area of interest is. Some of you have no clue maybe right now, but you will eventually. You might say, you know, I'm thinking Wi-Fi is kind of cool, or mobile technology, or maybe voice over IP or video security, setting up video cams and security. That's going to be a huge one in networking. You can study those specialties. You can look into them more. And the other type of certification. So let me get there real quick here. I'll stop on this one. Big one today, soft skills, which means people skills. A lot of networking folks years ago, we could get away with being rude and mean to people. Those days are gone. If you don't know what I'm talking about, you can watch like Nick Burns, the computer guy on SNL. Anybody seen that before? Jimmy Fallon did it years ago. Just Google it when you get home. Nick Burns, the computer guy, SNL skit. It's awesome. And then literally in that skit, he kind of dramatizes IT, but that's how it was basically. Not anymore. A lot of IT departments are sending the people like Dale Carnegie School of Sales and How to Make Friends and Influence People books to read, because customer relationships is huge, and people have to understand how to communicate simply to people that don't understand what an icon is, or don't understand what a printer is, or don't understand what a keyboard is, or whatever. Their computer's not on when they talk to you, and they want to know why things aren't working. So, when you find the computer's not on, that's usually not a good sign. And so you have to be able to deal with that positively and constructively. And so soft skills are huge in IT now. Let's talk about certifications. A couple ones I'll mention is CompTIA is the overriding umbrella organization that offers some vendor type certification. Microsoft, you've heard of them, right? You've heard of Cisco. Both of them have network certifications. But Network Plus certification that I want to mention, I don't know if it's going to be here, so I'm going to just write it in here. Network Plus certification. If you're interested in this certification, it's a middle row certification that it's not Microsoft, it's not Cisco. Let me know. I'll give you the study materials to start, which is totally free. The study materials are. And then once you are ready, it gives you like progressive study materials. It's kind of progressive testing. And what that means is when you start mastering an item, it takes you to another item in the test. And if you're weak on that area, it hammers away at you until you get better. And so it's progressive testing is how they do these. That's how they do these types of tests now. And so if you're interested in Network Plus, I recommend that. It's a very good service through CompTIA. Other ways to find a job, meyervc.org is a good one. We also have a job services here on campus, a career job services. Over in the Student Center, she sits over catty corner from the computer lab in the Student Center. Kelly Cooper is her name, and she's over student services, job services, and she can connect you with, helping you with resume, helping you with finding whatever job it is you're wanting to find, at work, finding employers to connect to you. So, other services that are out there we'll learn about this semester, but one of the ones I'll mention that we will learn about is the IEEE.org for student chapter. And then I would recommend, as I mentioned, the first of class, the Cocoa Heads Club that meets the last or third Wednesday of every month. We always have, usually throughout the semester, a local business come in and talk about their jobs that they have offered for students here at Rock Valley. So with that said, let's switch gears. I'm going to exit out of